Hello and hi guys, welcome to this video. We're going to be discussing the transpose of a matrix problem in this one. And let's go over the problem, then we can measure the complexity and write code. So I'm going to first read the problem. Transpose of a matrix. So you are given a 2D array of integers matrix, right? A function that returns the transpose of a matrix. The transpose of a matrix is a flipped version of the original matrix across its main diagonal, which runs from top left to bottom right. So top left to bottom right, and it switches the rows and column indices of the original matrix. And assume the input matrix always has at least one value. However, its width and height are not necessarily the same. All right, so here's an example given 1, 2 becomes, so 0, 0, 1 and 0, 1 is 2. That becomes 0, 0, 1 and 1, comma 0, 2. So we'll see how that works. Let's see it on the whiteboard. So our example is matrix is 1, comma 2, right? Now, if you look at this particular matrix, right, it is a, so this position is what? 0 by 0 is this position, which is 1. And the other position is 0, 1, right? And this is 2. Now, this is what? Row into column, position of elements. So now it says that row, if you see, this should become, it says what? 1, comma 2, right? Now in this scenario, if you see, this would be your 0, comma 0, and this would be what? 1, comma 1, 0, row and column, right? So we have to convert this into that, okay? Now, if you see the first one, right, 0, comma 0 remains the same. Second one, 0, comma 1 becomes 1, comma 0. So basically, row comma row and columns are flipped, right? Now let's take another example to understand it better. Let's say minus 7, minus 700, 12, minus 33. This is 17, right? Let's just say this is our new matrix, and this is 0, comma 0, 0, comma 1. This is 1, comma 0, 1 into 0. This is 1, 1. This is 2, 2, 0. This is 2, 1. Now, what should be my output? My output should be 0, comma 0. And then this becomes 1, comma 0, minus 7, minus 7, minus 7, which is 1, comma 0. And then this becomes 0, comma 1. 0, comma 1 is 400. 1, comma 1. 1 into 1. So that is 12. Right? This is 0, comma 2 minus 33 and 1, comma 2. Okay, that would be 17. So this will be our output in this case, right? 0, comma 0, 1, 0, 2. This is 1, 0, 1, 1, 1, 2. Right? So this becomes my end transpose of a matrix, right? Now the solution is very simple. So right now we have position we calculate as row into columns, right? We just have to flip it and make it column into row. If we just do that for the whole matrix, convert row into column, numbers into column into row, we would have a transpose right there. Now, what would be the complexity to do this? So total number of operations required would be equal to, just because we are doing for int I is equal to 0, right? I is less than row I plus plus. Then for int j is equal to 0, j is less than column j plus plus. Just because we're going to be using this, our complexity would be O of row into column. You can also write it as O of column into row. That doesn't matter. Here we are writing the complexity to be O of row into column because it's this one is n by, so this is not an n by n matrix, right? A matrix can be 3 by 3 matrix, right? 3 by 3 matrix, or it can be a 2 by 1 matrix, or it can be a 1 by 0 matrix. So in case your row and column are the same, the number of rows and number of columns are the same, then you can say row square, right? Or column square instead of row into column, right? Which is again same as O of n square. But since they can be different, it matrix could be 1 comma 0 1 0, could be of size 2 comma 1, 2 into 1 and all of that. So that's why, we're just going to do complexity as O of row into column. Now let's write a solution for this. So for this, I have already prepared an input. I have the input and I'm going to call this transpose matrix method. Okay. So see here, let me do for I is equal to 0, I is less than dot. Always to find in code to find the number of rows and columns, right? The simple way is if you want to find the number of rows, just do equal to matrix dot length. That will give you the number of rows. And to find the columns, you can do matrix of 0 dot length. That will always give you the number of columns. So if rows, right, row I plus plus equal to 0, j is less than columns j plus plus. Right now the matrix is row into column, right? So I don't want to change the original matrix. So that's why what I'm going to do is I'm going to create a new matrix called result new this one, and I'm going to give it the same number of rows and columns. Right now in the result I'm going to store the transpose. So result of just say I and j is equal to matrix matrix of I comma j, and transpose we flip them, right? So we change row and column, so it would become j into I. Now I might have to flip this one too, otherwise it's not gonna work. I'll put as row and column, and then we return the result matrix, right? Let me do one thing. Let me just do like integer result is equal to this one, so that we can check the output, and then I run the program. Okay, let's see the result. So now your matrix becomes minus 7, 100, minus 33, minus 7, 12, 17. You can also take another example where, what was our initial example we took? That was 1 comma 2, right? Let's see that one. So that is what? 1, 2, data 1. Okay. Now let's see what the response turns out to be. See, the response now is 1 by 2, right? So the transpose has happened. That's a very simple program. Just have to use 2 for loops and switch row and columns. If you do that, you'll always get the transpose of a matrix. And your complexity here becomes O of row into column. If it's given in the question that your matrix is going to be of size m into n, then you do this. If it says it's going to be n into n, then your complexity becomes O of n square, right? Or m into m, then your complexity becomes O of m, right? That's the problem. Thank you so much for your time. That's it for this video. We'll see you in another video with a different question.